To you. You're welcome to this lesson. And this is the first lesson for this term. Now, for this third term, we will start with correcting the questions that you guys just did. Now, notice that third term is a very short time. And because of that, we will try to do our very best, in maximizing doing the useful thing and minimizing doing the things that will not help us that much. That then means if I give you an activity, you make sure you do it. Then if you don't find it easy at some point in time, you have to ask early enough, because the time we have in third term is a very little time. Now, for this lesson, as I indicated, we will be discussing the solutions to the question that you guys just did. And the questions that you did starts with the question 1,1 with these instructions. That is, for each of the following questions, choose the correct answer. Mark a cross X over the letter A, B, C, D, which corresponds to your answer on the answer sheet provided. So very much like trying to say that these questions that you will be having right here below have got multiple choices to make. You can choose, for example, the first one, A, if it's the correct one according to you for the given question, or you can choose the second one, B, or the third one, C, or the other one, D. Now, for each choice that you make, you have got to put a cross. That is, you put a mark, you make a cross. You make a cross over the letter that you have chosen. Now, for this correction, we will just be putting a mark from here just to help you understand what the correct solution would be. Now, the first question is, which statement is true? Which statement is true? The first statement is A. It states that all integers are natural numbers. That all integers are natural numbers. What is this supposed to mean? And what are integers? Well, integers are numbers that appear on number lines. They are sometimes negative. That is, they decrease to negative, and they decrease what? They increase to positive values. And then, are all of them natural numbers? Well, when we look at this diagram here, one thing you notice is that natural numbers starts from 1, then to 2, to 3, to 4, to 5, in that order. That is how a natural number increases. Now, these natural numbers that increase in this order from 1 to 2 onwards, they don't include negative values. And so if there is a statement which is asking you whether all integers are natural numbers, that statement is not true. Because you can see here, integers has got negative values like -2, -1, and 0. But natural numbers do not even have 0. Natural numbers are used for counting. For example, when you want to count something, maybe when you want to count the number of houses, when you want to count the number of, shoes that you have, when you want to count the number of sweets, you use the numbers like 1, 2, 3, 4, and 5 like that. Those numbers you use for counting are known as natural numbers. Integers are very different numbers from natural numbers. Though part of the numbers, or in other words, part of the numbers, some of the numbers that are known as integers are also natural numbers. So that statement is not true. Well, that means A is not correct. Then we move on to B. All real numbers are rational numbers. What are rational numbers? Well, rational numbers are numbers that are formed when two other numbers are divided. So according to this statement, are all all real numbers rational numbers? No. Then the next, all integers are real numbers. Well, what are real numbers? Real numbers are numbers that are used for counting, or very much are numbers representing continuous entities or continuous quantities. For example, when we are grouping things and counting things that keeps on increasing or are on continuous, we call those numbers real numbers. That is how we specify real numbers. And now when you look at part C, they're asking that are integers real numbers? Well, when you look at integers, as I indicated earlier, integers are numbers that we use what? That we use on number lines. And these numbers are continuous. For example, you see like from 0, you have going to -1, then to -2, meaning from -2, we can continue to -3, to -4, to -5, to -6. They keep on decreasing like that. Then when we get back to 0, you can also start to look at it that from 0, we have got 1, then we move on to 2, then we move on to 3, then we move on to 4, you know, in that continuous increasing order. And so we can therefore say that all integers are real numbers. That means C forms part of the solution. So we then have got to do what? We now have got to indicate it. So for this, let's just draw this. Yes, let's draw just that. To mean what? To mean C is the correct one. The next thing we want to do is we move to the second question. Oh, this thing is, this one has not stayed there. Let's first erase this. Yeah. So this one was C, the correct one was C. Then the next being, let's put this again. Yes. Then the next question is calculate the value of this expression. Well, we have the square root of 144. The square root of 144. Let's remove this. So let's see how that is going to come. So we are dealing with the square root of 144 that has got to be added to what? The square root of 144 that has got to be added to 25. Now the thing you notice here is that, just increase the size a little bit. Yes, like that. So one thing you notice here is that these two numbers can be added. And when we add these two numbers, what do we get? Well, we'll be getting 165. And so the square root of 144 added to 25 will now become the square root of 165. Is it? No, 169. Now, notice that the square root of 169 is 13. So we get to the question and we check. Where is 13? 13 is right here. So for question 1.1, it has been C. Question 1.2, it is what? It is B, because that is the square root of 169, which is 13. Then when we move on to the next question, which is the component, okay? That is the component of 63 is, now, when we are talking about these things of components, especially in angles, the thing we notice here is that angles that are called complementary, they add up to 90 degrees. Okay, there is a very close relationship that you can easily mix them up between complementary angles and supplementary angles. Now, complementary angles add up to 90 degrees. Then supplementary angles add up to what? Add up to 180 degrees. This question is talking about complementary angle. That is, the complement of 63 degrees is, it's very much like trying to say, which other number can we add to 63 to get what? To get 90 degrees. And how do we get this number? How do we get this other number that we need to add to 63 to get 90 degrees? So now to find this number, well, we can subtract 63 from 90. And when we subtract 63 from 90, what we get is the number which we must add to 63 to get 90 degrees. And so what is that number? Which number do we add to 63 to get 90? Yes, let's check this right here. Okay, so we are going to be having 90 minus 63. 90 minus 63, what do we get from it? We get 27 years. So what that means is the number that we must add to 63 to get 90 degrees is going to be 27 degrees. That will make 1.3 have the solution A. Then the next thing is 1.4. So 1.4 is asking for the value of x plus 2x. So it's like we have got 2 of some quantity. You could think of it like, you have got 1 sweet, and now you have got 2 more sweets. When you add all of them together, you will be having 3 sweets. Not 3 squares, not 2x squares, but it will be 3 sweets. So let's say x represents a sweet. So 1 sweet plus 2 sweets gives what? 3 sweets. That will give us the solution C. So the answer to question 1.4 is C. Then the next question is question what? Question 1.5. Now question 1.5 is asking us to find the solution to 3 into A plus B. So what would be the solution to that? Well, let's see how it's going to be expanded right here. So we have got 3 into A plus B. Well, suppose we have this, suppose that this is what we have. Now, what is the answer going to be? What would be the solution to this? What would be the answer? How do we handle this? Well, now notice that because this 3 is outside the bracket, to simplify this, we must multiply 3 with this A, then the 3 with B. Now, the thing you notice here is that when you multiply 3 with A, what you get is 3A. Then you add that to what you get when you multiply 3 by B. Now, when you multiply 3 by B, what you get is 3B. And that becomes the answer to the question. So we check. So 3 into A plus B gives us 3A plus 3B. That would be the solution, because this 3 which is outside the bracket has got to multiply A, then later this 3 must also multiply B, giving us 3A and 3B as given here. Then the next question is question 1.6. Now, question 1.6 is asking that what is the value of the expression 3x minus 4 when x equals to 9. So what they're trying to say here is that at first, there was something that was not known in the expression. Right now, the value of that quantity is known. So if that value of the quantity is known and it is inserted there, it's like you have got a business deal, you are arranging, you're trying to make a plan to do something, but you are like, well, let's wait for Monday. By Monday, I'm expecting some good news. Then before Monday, you get this thing. So now when this good news comes in, you have to introduce it into the arrangement that you had before. So in mathematics, this is how it appears. What do we have? Well, the expression we have is 3x minus 4. So 3x minus 4, let's have it right here. 3x minus 4. That is the expression we have. Now, that is what we had before. Right now, the value of x is known. What's the value of x? The value of x is given as 5. So the question is, what is the value of that expression, 3x minus 4, going to be when x equals to what? When x equals to 5, okay? So now when x equals to 5, what we are going to have is 3 times this value of x, okay? Which is what? Which is 5 minus 4. So notice that what we will get here, in this case, is going to be 3 times 5, which is 15, minus what? Minus 4. So 3 times 5 minus 4, that is 15 minus 4 will give us what? Will give us 11. And so checking on to what we have here, 11 is B. So that means the correct answer to this question is B. Well, the other thing that we now want to look at is what? 1.7. Question 1.7. Now, question 1.7 is saying we have to replace the sign star here with the correct sign as one of this one. So we can either put less than sign, or we can put equal to sign, or we can put greater than, or we can put greater or equal to. So, well, when you look at negative 15 and negative 3, which one is bigger? Which one is smaller? Which one is the same? Are these numbers the same? Obviously, they're not the same. You see, this is negative 15 and this is negative 3. The two are not the same, meaning B is not one of them. Then, when we look at this sign, this one means less than. So is negative 15 less than negative 3? Is that the case? Or negative 15 is greater than negative 3? How do we decide that? Okay. Now, notice that when we have a number line as an example, the numbers that keeps on getting or keeps on going to the left, those numbers keeps on getting smaller and smaller and smaller. That is like when we start from 0. Then the numbers that moves to the right, like 1, like 2, like 3, like 4, those numbers, they keeps on increasing. And the next number is greater than the previous number, you see? So when you begin to start counting from 0, then you count on the left negative 1, then you get negative 2, then you get negative 3. You notice that the further you go to the left, the smaller that number will be. So that means negative 15, which comes much later than negative 3, is less than negative 3. So in general, the number or the sign that we are going to put is the less than sign. And so we can therefore say negative what? We can therefore say negative 15 is less than what? Is less than negative 3. That becomes the correct sign to put. Then after that, we move on to the next question, which is 1.8. Now, question 1.8 is asking for the common fraction. Now, the decimal fraction or the decimal given here is 0.36. So now let's just have it put right here, 0.36. Now, notice that if you are given a decimal fraction and you're supposed to change it to a common fraction, the first thing you want to do is to write this decimal fraction as what? As a proper or as a normal or common fraction. You do that by writing it or placing it over 1. Okay, notice for now, there is no difference between this other one on the left and this other one on the right. It's basically the same. The first thing you want to do is to write the number given or the decimal given out of 1. Okay, then the next thing you want to do is this decimal which you have now got. Okay, which is what? 0.36 for the numerator and 1. The next thing you want to do is to multiply these numbers, the numerator and the denominator, following some rule. And what is the rule in this case? Well, for every number which comes after the decimal point, you multiply by 10. So that means for 3, that is to move the decimal point from, say, here to this point, we have to multiply by 10. Then from this point to this other point, we multiply by 10, saying for every number which comes after the decimal point, you multiply by 10. How many numbers do we see here coming after the decimal point? We have 1 and 2. There are 2 numbers coming after the decimal point. That means the numerator must be multiplied with what? With 100. That is 10 times 10, okay? For every number coming after the decimal point, you multiply by 10. So 10 times 10 is 100. Now notice that because you have multiplied the numerator by 10, you also multiply the denominator by 10. And when you do that, what you get in this case is going to be a new value. And what is that? Well, the numerator will now change to 0.36. This is 0.36. Just change this. So from 0.36 times 100 to 36. Then this other one remains the way it is. Now notice that when we divide 36 by 100, this one can be reduced. In other words, 36 can be divided by some other number, say 4, so that we get what? 9. And 100 can also be divided by 4, and that gives us 25. So this is the value of 0.36 in common fraction. And so what is the solution from here? We check 9 over 36 is D. So the solution to question 1.8 is D. Now the next thing we want to look at is question 1.9, which states that we write 5 divided by 8 as a percentage. 5 divided by 8 as a percentage, well, let's first have it right here. This is 5 divided by 8. So 5 divided by 8 as a percentage means we have to do what? We have to multiply this value of 5 divided by 8. Well, this one as a percentage means we have to multiply 5 divided by 8. That is the value that we get times 100%. Yes, that is the meaning of expressing it as a percentage. Okay, as a percentage means we have to multiply it by 100%. And so what is this going to be? Well, as a percentage, 5.8 as a percentage, this is going to be 5, rather not 5 divided by 8. Well, let's see, 5 divided by 8. So 5 divided by 8. This is going, yeah, 0.625. That is what we have got. 0.625. 625. That we still have to multiply with what? With 100%. So what do we get when we multiply this by 100%? Well, this is going to be 62, what? 62,5. Now in percentage. So yes, this is the solution to 5 divided by 8 expressed as a percentage. And so looking at the solution here, that means the answer to this question is going to be C. Then the last question for part 1 is 0 times 1 divided by 1 times 1. What would be the solution of this? Let's see what comes out. So we have 0 times 1 as the numerator. That is what? 0 times 1 that we have to divide by 1 times 1. So what would this be? Well, notice that 0 times 1 is 0, okay? Then 1 times 1 is 1. And this should give us, what is 0 divided by 1? It's very much like trying to say 0 is like nothing. So think of if you are to divide nothing by 1, or if you are like to give nothing to someone. You know, dividing is like sharing something. So yes, you have got something. Now you would like to give that something, not really that way. You got nothing, okay? You got nothing, and you would like to give that nothing to someone. So have you ever thought of giving nothing to someone? Well, giving nothing to someone is very much like giving nothing. It's like not giving anything. And so if you have not given anything to anyone, you have given nothing. And that is the solution. Notice that there is a difference between this and what you would have got if the numerator in this case was the denominator. Suppose that we were having something else like this. Let's say you were having 1 times 1 for the numerator. Then for the denominator, you had 0 times 1. Well, that would mean you would have the numerator as 1, okay? Then the denominator as nothing. So now that would mean you would like to give something to nothing, okay? You have something to give, yes, but you have no one to give to. So what is that going to be then? Well, mathematically, the solution to this is called undefined. If you're using a calculator, 1 divided by nothing would be an error. But the mathematical explanation is that it doesn't have a value. 1 divided by 0 does not have a value. It is not defined. It does not have a definition. In other words, it is an error. You cannot have something and you want to give it to nothing or to nobody. You see, it doesn't make sense in mathematics, and that becomes the what? The solution to the question. So our question is this one, and the solution is 0. So we would move here and see what would it be? Well, it is B. So yes, for this lesson, we are stopping on this number, that is 1.10. And yes, that is where we have to stop for now. We will have to continue with the next lesson later. Thanks for being there. We will link up some other time.